Imagine standing on the ancient surface of Mars, looking up at a mountain so massive it seems to bend the horizon itself. A structure so enormous that it rises not like a peak, but like a continent lifting into the sky. This is Olympus Mons, the Titan of Mars. A volcano so large, so impossibly wide, that its presence alone rewrites everything we thought we understood about the red planet's past. But behind its staggering size lies a story far stranger and far older than most realize. Because Olympus Mons isn't just a volcano. It is a relic of a Mars that once pulsed with heat, movement, and geological fury. A Mars that was alive in ways we rarely imagine today. And the secret locked inside its colossal slopes is this: Olympus Mons may be the key to understanding the red planet's lost era, a time when oceans shimmered beneath a thicker sky, when volcanic heat shaped climates and landscapes, and when Mars may have been far more Earth-like than we ever expected. But the real mystery isn't how Olympus Mons grew, it's what its sheer existence reveals about the deep interior of Mars. Why did this volcano reach heights 3 times taller than Everest? Why did it spread wide enough to swallow small countries whole? Why did it erupt for millions of years while other planetary volcanoes faded into silence? The answer lies beneath the crust, hidden in a planet whose interior cooled unevenly, trapping heat pockets that fed Olympus Mons like fuel lines into a cosmic engine. But here's where the story becomes even more compelling. Recent data suggests that the base of this mountain, this frozen giant, may still hold warmth. Subtle temperature gradients, ancient magma remnants, cavities formed by geological forces that shouldn't exist on a dead world. And if Olympus Mons preserved warmth far longer than expected, then it may have preserved other things as well, things far more precious. Because warmth means liquid water could have survived in hidden pockets beneath the surface, and where water existed, life could have once followed. So tonight, we descend into the Titan of Mars, not to admire its size, but to uncover what it reveals about a world that once burned with possibility. To truly understand Olympus Mons, we must step back into Mars' deep past, long before it became the cold, dusty world we know today. Billions of years ago, Mars possessed a thicker atmosphere, warmer temperatures, and a magnetic field strong enough to shield it from the sun's destructive radiation. In that ancient era, Mars was geologically alive. Volcanoes erupted across the landscape, shaping continents and feeding rivers of lava into basins that may once have held water. Olympus Mons was born in this chaotic environment. But something unique happened beneath it. Earth's continents drift on tectonic plates, constantly shifting and dragging volcanoes away from their heat sources. On Earth, a hotspot produces a chain, Hawaii, for example. But Mars never developed moving plates. Its crust stayed locked in place. So when a massive plume of molten rock pushed upward from deep within the mantle, it fed the same point again and again and again. For tens of millions of years, Olympus Mons grew without interruption, inflated from below, like a slow, unstoppable bubble of fire. But the real revelations come not from its height, but from what lies beneath the volcano's base. Orbital radar has detected enormous subsurface structures around Olympus Mons, collapsed chambers, cavernous voids, and patterns that look remarkably like the signatures of ancient magma plumbing systems. These aren't random formations. They imply a long and complex volcanic history, far more active than we previously imagined. Even more compelling are the minerals exposed around a volcano's base. Some are known to form only in the presence of water. That suggests that at some point in Mars's history, molten rock from Olympus Mons interacted with groundwater, creating hydrothermal systems that may have lasted for thousands of years. On Earth, such environments are havens for microbial life. Heat plus water plus minerals equals habitability. Suddenly, the Titan of Mars becomes more than geological curiosity. It becomes a potential cradle for past life. And while the surface of Mars long ago dried and froze, evidence of its warm interior persisted beneath Olympus Mons far later than expected. The implications ripple across every theory about Mars's transformation from a blue world to a red desert. But Olympus Mons doesn't only reveal Mars' fiery past, it also exposes the violence, instability, and geological collapse that reshaped the planet as it cooled. Surrounding the volcano are enormous megaslide deposits, some stretching hundreds of kilometers, dwarfing any landslide ever observed on Earth. These colossal debris fields indicate catastrophic collapses, triggered by seismic shifts deep beneath the volcano's flanks. Imagine entire sections of a mountain, each larger than a small state, breaking loose and sliding outward across the plains, carrying billions of tons of rock. What force could cause that? One theory suggests that pockets of subsurface ice, heated by volcanic activity, melted and destabilized the ground. Another proposes sudden shifts in magma reservoirs, cracking the crust and sending waves of pressure through the mountain's foundation. But the most intriguing possibility involves massive lava tubes, vast hollow tunnels beneath the surface. Some of these tubes might still exist, perfectly preserved in Mars' frigid climate. Others may have collapsed long ago, causing the enormous landslides we see today. If lava tubes still extend beneath Olympus Mons, they could hold clues to Mars' interior, and maybe even remnants of ancient microbial life, shielded from radiation and preserved in stable conditions. Meanwhile, seismic data reveals faint, consistent vibrations under the region, not enough to indicate a waking volcano, but enough to suggest that Mars's interior remains active in subtle, hidden ways. Slight shifts, settling layers, gas movements, thermal transitions. Such activity may be weak, but its presence hints that Mars is not entirely geologically dead. And that brings us to a crucial point. Olympus Mons might be the last major witness to Mars' final moments of internal heat, a colossal structure that cooled slowly, preserving warmth long after the planet's global volcanic activity faded. Beneath its gigantic base may lie a frozen time capsule, a snapshot of what Mars once was, and perhaps hints of what it might become again. When humans explore its slopes one day, they won't just be climbing a mountain, they'll be stepping into the planet's deep memory. Looking toward the future, Olympus Mons stands as one of humanity's most important targets for exploration. Not because of its size, though its sheer scale is breathtaking, but because of what it may reveal about Mars's buried history. As upcoming missions prepare advanced radar arrays, seismic sensors, and heat-probing instruments, Olympus Mons is expected to become a scientific focal point unlike any other location on Mars. If future orbiters detect active thermal signatures below the surface, it would imply that some form of magma may still linger deep underground. That would reshape our understanding of Mars from a cold, dead world to a partially living planet, one with internal processes still unfolding. Even more exciting are the possibilities for life. Hydrothermal systems beneath Olympus Mons may have persisted long enough for microorganisms, if they ever existed on Mars, to survive in isolated pockets. The lava tubes beneath the mountain could hold stable temperatures, shield harmful radiation, and preserve evidence of biological activity for billions of years. Exploring them would be one of humanity's greatest scientific achievements. And perhaps one day, astronauts will reach the foot of Olympus Mons, facing a mountain so enormous they cannot see its summit from ground level. They'll traverse ancient lava plains, descend into caverns created by long-cooled magma, and uncover mineral layers that tell the planet's story from its fiery birth to its icy present. They may discover thermal vents still faintly warm, frozen groundwater trapped in porous rock, or even chemical traces indicating that life once clung to this hostile world. Olympus Mons is a reminder that planets evolve. They breathe heat, shift, roar with fire, and eventually fall silent. But silence does not mean emptiness. Beneath this titan of Mars lies the record of a world that once fought to stay warm, to stay alive, to keep its oceans and atmosphere intact. And though Mars ultimately lost that battle, its greatest volcano remains, a monument to everything the planet once was and everything it still hides beneath its surface. In the end, Olympus Mons is not just a mountain. It is a story, carved in stone and frozen in time, waiting for us to finally decode.